Well, good morning, everyone, again. Thank you for coming up. So we're going to, please enjoy the breakfast. It has two types of sausages. It's called top of the morning breakfast. So it had a pretty good food, and we did it last year. So I hope you had a chance to enjoy the view in Galveston. So we come in here and we love this place because it has its own unique vibes. So this is the view from the place where we stay, enjoying the sunrise. So hopefully you had also some time to expose to that beautiful nature. The weather cooperated. So the humidity was low, and so now it's time to hopefully to learn something, and this is what we're here for. So the workshop that we designed a couple of years ago, and we came up with a different format where instead of us talking about how great our products are, we let our customers share the experience, so that will benefit you as users doing similar things or similar application. So you see here on this picture, that a picture from the last year workshop, right? So there was a full room, and it was pretty successful. So now we're kind of building a history, because one of our presenters for this workshop, Randy from CADGen, he was at this workshop. He was as a attendee, so he listened to it, and then we ended up talking. He got our products, and here we go, he's going to be presenting. So this is the kind of thing we would like to carry on. Hopefully some of you is going to benefit from what you're going to hear and learn today. So a couple of words who we are. If you guys, some of you don't know who we are. We are specializing on ICP and ICP-MS consumables. And in two words, we're one-stop shop for anything that you need to do to run your ICP. So we started our business in 2004, and then we've grown up to that point. So we started with two partners who founded. So my colleagues, Doug and Bruce, who greet you when you were coming in, and myself. So between us, it's scary 85 years of experience. I work for instrument manufacturers. So and you have some other choices, obviously, but I think in two main things that what separates us, there are two things there. So one, so coming from this experience, so I worked in the lab most of my life, and my business partners were involved in atomic spectroscopy. So we think we understand, not only do we think, we're sure that we understand the little details or small details of application, and actually we're going to challenge you. So if you're welcome to come up with any application. If we're going to be stumble across it, you're going to have a free breakfast today. So the other thing is, major thing is, we design and manufacture and develop innovative nebulizers. So today, the nebulizers for ICP, they came out in somewhere in the mid-90s, something like 1974. And believe it or not, since up to now, the basic design of, it was actually called Meinhardt, sometimes you hear that word. It was Dr. Meinhardt who designed this nebulizer that's now in the industry referred to CONCENTRIC and has some now different names. But the basic design did not change. It is the same thing that worked back years ago. So we coming up, and the field was a little bit stable. There is no major innovation there, but we believe we come up with innovative nebulizers. You're going to hear from the speakers today how they use it, what the benefits for you, and some of the names that, some of the brand names that you may use in or hear in the industry when refers to the these nebulizers are sea spray or micro mist or one neb, and our technology has the improved dual channel. And then I'm not going to get into the details, so I leave it up to our speakers. So with that, let me introduce you to our first speaker, and let me please bring his presentation up. Dr. Jesus Acapulco is the lab application specialist at Analytik Jena. He focuses on teaching, training, and supporting scientists, engineers, and technical professionals in the use of chemical analysis, instrumentation from Analytik Jena. Jesus aims to bridge the gap between the complex technology and real-world applications. This is what we're focusing on, real-world applications. His hands-on work involves developing solutions tailored to the unique challenges faced by the researchers, engineers, and customers, ensuring they get the most accurate, precise, efficient, and insightful results. So let's welcome Jesus to the podium. So let me pass him the microphone.
Flip it here.
Yeah.
Thanks,
Okay, it's all yours.
Thank you very much, Sergey. Good morning, everyone, and thank you for being here. So today I'm very happy to share with you our collaboration with Texas Scientific Products with this project, and hopefully I can deliver to you some findings, some vital findings that you can take home and apply it in your laboratory. So essentially, for today's topic, I'm going to talk about comparing two typical nebulizer, the concentric nebulizer and the non-concentric nebulizer, which is the dual channel from Texas Scientific Products. So just like what Sergey mentioned, there's a history, very rich history in terms of ICP. If you could see on the top side of the slide, that's the development of the ICP. It started at 1960s, where it was developed, but it was commercialized at around 1970s and 1980s. So during that time, when the development of the ICP was, on the works, people or researchers in the field of the nebulizer thought about how can they introduce the sample in the plasma. Luckily, there's the atomic absorption spectrometry already existed, so they essentially took that technology, the nebulizer of the AES, to the ICP. And that's what Sergey is telling us, that since then, like since 1960s, the technology has still stuck on that kind of idea. But at around 1990s, in the 1990s, a big player of this chemical analysis came in, which is the ICP-MS. That changes the game, because people or researchers were focusing more on like micro introduction of samples, because the ICP-MS showed really promising results in terms of like very low concentrations analysis. So there was like the development of the nebulizer shifted significantly to the ICP-MS. But there's still ongoing works with OES until 2010. It was our company, Analytik Jena, joined the business in the ICP-OES, and then finally, now at the 2020s, we have released our new model of the ICP-OES, the PQ9200, and also around this year or this century, this 2020s, that's when the first patent of Texas Scientific Products of their ultimate nebulizer came in. So yes, just a brief overview about an ICP-OES. There's a lot of moving parts. Essentially, you have the sample introduction, and then here comes your nebulizer, and then it goes to a spray chamber going to the plasma. And then from the plasma, it is where your elements are going to be measured. So essentially, atoms have electrons, and when you excite one electron, and at a short amount of time it goes back to ground state, it will release light. So that light is very unique to each element, and that's how ICP-OES measures each element. So for today's talk, like what I said, we're going to be focusing on nebulizers. Essentially, the sample introduction is very important. It's a key to get good and reliable, accurate, precise results. Like what I said, we have just released our new model of our ICP-OES early this year, and here's a QR code if you want to check it out, but also it's in the lounge, the new products over at the exhibitors hall, and we also have it on our booth. So yes, the main topic of this presentation is going to be comparing concentric and the improved dual channel. So over the left-hand side, you see a zoom-out view of a typical concentric nebulizer. Essentially, your argon comes into this channel here, and then your sample goes in here. And what happens is that argon is somehow around the sample. So if you look at the cross-section of the tip, you see the green line or the green color, that's the argon flow, and the red shaded color is the sample. So what happens on the tip is essentially there's this making this mist of a Venturi effect. So you see the sample has been carried out by the argon around the sample and making this uniform, very nice mist. However, for the improved dual channel, it has the same overview zoom out structure, but it has a very significant difference in terms of delivering the sample. If you look at the cross section here, you can compare that the sample the diameter of the sample channel is much more bigger than the concentric typical concentric nebulizer. And there you also see the channel for the argon. Essentially, the argon is not around the sample, but it's in a different channel where the liquid sample starts to, a bit of a capillary action, and then when it hits this high velocity argon flow, then it starts to produce this mist. That's basically the core difference of the concentric and non-concentric, especially improved dual channel from Texas Scientific Products. So for today, two applications. We will be talking about two applications. One is crude oil and one is brine. So some of you might know that in crude oil, there's a lot of challenges there. Essentially, your sample is just a really totally different matrix, not just water. You can just put water there and then just run your ICP-OES. It doesn't matter. But for the crude oil, you have high carbon content, you have the difference of viscosity, and you have potential high particulates. Essentially, for crude oil, you have a lot of different carbon chains of your molecule, and that also affects, for example, if you have 50% C5 versus containing, let's say, half of that is some impurities of C6 or C7, then it changes the viscosity and the property of your matrix. Not only that, the particulates is also another thing, because it can clog your sample introduction system. And the last application that we will be talking about is brine. And for brine, it's closer to, let's say, aqueous sample, but essentially you have a very high levels of total dissolved solids. And the challenge about this is that it starts to crystallize in your tips of your injector, starting to affect your results. And also it has the potential of different samples contains different levels of particulates. So yes, here, this is an example of one of our customers' sample for their crude oil. And basically that's a vial that's like flipped upside down. So it has like a very, like a thick, like a high viscosity characteristic. So what we did first is we normalized the plasma. So we essentially we cannot compare two different nebulizers if the plasma is not like comparable. So it's not like apples to apples. So for us to compare apples to apples, we need to normalize each conditions with their plasma. If you look at here on the left-hand side, that's the narrow orifice. This is like what I mentioned in the introduction, you know, researchers in the nebulizer industry, they started to develop micro nebulizers. So this is the micro nebulizers. And essentially when I lit up the plasma first, I'm not sure if you could see it there, but down close to the injector, you see a yellow glow of light. That's essentially not a good profile of the plasma, so we need to get rid of that. So in order to get rid of that, I increased the nebulizer gas flow from 0.30 liters per minute to 0.50 liters per minute. Now I was able to make this really nice, what we call bullet, or the channel of the plasma. And then once I've got like a good parameters to work on, I moved on to the improved dual channel nebulizer. Essentially, when I turn the plasma on, you know, this is the first run or the first lit of the plasma, no problem, directly showing you the nice profile of the plasma. And here, the main point here is that the level of the bullet needs to be the same for both nebulizer. So what I tried to do is decrease the nebulizer going to the middle coil of our RF generator. So now you can see this parameters here is now going to be comparable to this parameter in a sense of the plasma profile. However, when, you know, it's very typical in the lab that once you get like good conditions, you're like, yes, I'm gonna go get some results, and suddenly something happened, like, oh my, what's happening here? Like, I was so excited to get some results, but then when I tried to get numbers, you know, the narrow orifice nebulizer, I couldn't lit it anymore. I tried to like clean it again, and lit the plasma. It was just a lot of things that I had to like work on. So that was a really big challenge, and it didn't make sense to just, you know, push further with this nebulizer. But essentially I moved on to a wide orifice concentric nebulizer. So this enabled me to go back again to normalize the plasma. So now the bullet of the plasma is around the third coil, which I also made the same plasma profile for the improved dual channel. And now I was able to get numbers and, you know, a good comparison of the concentric versus non-concentric. So I just want to touch base in terms of like the standards and sample preparation. If you are working with oil samples, then I bet you already know in details how to like make these standards and samples. But essentially, we have a solvent with internal standard, and we have the base oil. These are prepared by mass. So depending on the mass of the base oil, it's gonna be normalized, adding the standards in. And then finally, we have the spike sample. Essentially, we have amount of sample and the standard, and then checked the result. So I'll be showing that with you in a couple of slides from now. So yes, so here's some numbers. This is basically monitoring the internal standard deuterium for the concentric and the improved dual channel nebulizer. What you see here is a very interesting phenomena, because, you know, for the concentric nebulizer, we have 3 calibration standards: calibration 0, 1, 2, and then after that I did a rinse with a blank, and then came in the sample. It's the same sample but injected 3 times, or like analyzed 3 times. But you see here there's a obvious drop from 100% to around 80% once it goes to the sample. We did not see that behavior when we use the improved dual channel nebulizer. As you can see, after the 2 blanks, it stayed about close to 100% recovery. Essentially, I was thinking like, what's the reason behind this? One of my thoughts is like, since the concentric nebulizer is very sensitive to like making these mist, so just a change of your viscosity will drastically change the flow of your internal standards or your sample. Here is a video showing you the spray chamber for both concentric and non-concentric. What you would see for this kind of application is that the mist of the spray chamber is like, it's like breathing, it's like pulsating. And then if you look at closely to the tip of the nebulizer, you see this like back and forth movement of the sample. I believe this is coming from differential pressure. As we all know, concentric nebulizer, they are self-aspirating. So from that self-aspirating, it has a pressure where it brings in the sample already. And now you introduce the peristaltic pump of your ICP-OES. Now that's a different pressure. So you have this like differential pressure. But we did not notice that or did not observe that for the improved dual channel nebulizer. It was just making this nice mist, nice uniform mist and going to the plasma. So in terms of the sample spike recovery, both of the nebulizers showed within the plus minus 20% error. However, I have to mention here that the improved dual channel showed closer to 100% recovery than the concentric nebulizer. Yes, so let's move on to the next application, which is the brine sample. Here is a typical customer sample, brine sample that has about 6% sodium, 3% calcium, 3% magnesium, and 2% strontium, and then some trace metals. So here, again, you know, we have to compare apples to apples. We have to normalize the plasma, and these are the conditions that I was able to do. For the concentric nebulizer, they have this technology called non-salting, or like high salt concentric nebulizer. So that's what I used for this case. And then what you see here, it's very interesting because like the main difference is that the nebulizer gas flow for a concentric nebulizer showed to be a little bit lower than the improved dual channel. So here you have 0.9 liters per minute, but for the improved dual channel we have 1 liters per minute. But what I've seen is that even though this is like small, if I put this to 1, you see this bullet here, it moves like significantly. So I had to stay in the range of 0.9 because I couldn't really compare it analytically. And then the next thing I tried to normalize is the formation of the mist. One thing you will notice here is that for the concentric nebulizer, from 1 mil per minute to up to 2 mils per minute, we see a good, you know, mist generation. Even the fact, or like if you see here the baffle, like the inner channel of the spray chamber, you couldn't see it. It's like a fog, like a nice mist generation. On the other side, for the improved dual channel, at 1 mils per minute, you can still see the baffle. It's not as good as the generation of the mist for the concentric. However, if you go to 1.5 mils to 2 mils per minute, you then see a very nice mist generation. So for the sample analysis here, we did a method of standard addition. I think the method of standard addition is very nice in order to consider the matrix. However, it's just a lot of work to do because you have to like spike your standards, but essentially that's the method that we proceeded to. And then here's some results in terms of yttrium internal standard. Essentially, after the blank, since the sample is, you know, very different with water, it has a very different effect of the plasma. So that's why we see from the blank it drops to 90%, and then goes back up to 100 with the blank and QCDL. But the important part here is that when you analyze your sample, it goes back to where the nature or the environment or the system of your plasma is. For the eggshell view, there's no worries, but for the radial view, we see here a very interesting difference. Basically, the improved dual channel showed to be a much more stable signal and even like closer to 100% recovery. And then here is a result of our sample analysis, basically just monitoring the low concentration elements. Both of the nebulizers showed to be around close to 100% recovery. Some of the elements showed a little bit recovery, like magnesium and iron, but that's particularly, I think it's just coming from the different lines that we've been observing. But essentially, it's still a work we're still interested in moving forward and investigating it. And on the bottom side, we have the calibration comparison of the non-salting concentric and the improved dual channel, basically showing almost similar case. So in summary, I want to share to you that there are pros and cons in different types of nebulizers. In terms of this application, the improved dual channel nebulizer showed to have a lot of benefits moving forward if your lab or if you would like to analyze crude oil and brine samples. Yes, I just want to say we have our booth here. Probably some of you have already seen our booth. It's right after the entrance. You would not miss it. Please feel free to find me or our lab manager, Jess, or even Pooja, our sales manager. And actually, our new ICP-OES is on display at the lounge. And I would like to share a useful discussion here, lots of discussion with Jess and over our people at HQ at Jena, Germany, Killian and Max. And I also want to thank Sergey. There's a lot of discussion of this collaboration, and feel free to scan the code. You will contact him, and like a lot of useful information you can get from him. Thank you very much.